Hello everyone, welcome back to my additional maths and mathematics channel. So today I would like to discuss about the additional maths paper 2. This paper is from MRSM 2020. So I will just focus on section A. Right, so for section A, for paper 2 for additional maths is quite important. So let's see the first question for section A. So this is actually a topic which is quite tough for many students. So the moment you see Trigo, you will say, I cannot go, I cannot do. Right. Actually, I just want to tell you that Trigo is considered easy because it won't be so hot. Right. It's a cold storage question. Well, how to do proving of Trigo? Now I'm going to teach you how to do. Let's see. You are asking to prove like this: sec square A minus tangent square A over tangent A plus cotangent A is equal to sine 2A over 2. Okay, let's say you are not sure how to do. Basically, I'm sure you know how to open up the formula list, right? So you find the related one. So which one is related to this question? So we just highlight. So we see the sec square and tangent square. So we go to the formula list, right? So we just highlight. Okay, so let's circle the formula that we're going to use, this one. And we have another one which is sine 2A, right? So you just copy the formula that you want to use, okay, and then you just write beside the question. So I'm going to copy sine 2A formula, which is 2 sine A cos A, and then sec square A is 1 plus tangent square. Alright, so basically when you want to do proving of Trigo, you always start from the one which you can do something, which is this side. Maybe sometimes you have to start from both sides, okay? So we start from left hand side and then we will study the right hand side and we see whether we can match them, okay? So now I'm going to start with the left hand side. Let's see how I do. I will copy down the formula, right? Just now is okay, first of all, step 1, we just write the left hand side, sec square A minus sec square A minus tangent square A over tangent A plus cotangent A, right? Okay, so this is the left hand side. We start from one side and we show all the steps until we can get the right hand side, right? So just now I just asked you to copy down the formula. Sec square A is equal to, you don't have to memorize the formula, you just know how to pick the right formula. Sec square A is equal to 1 plus tangent square A. Copy the formula and don't change the formula, okay? Make sure you copy the right one. And another one is sine 2A is 2 sine A cos A. I didn't memorize, okay? Okay, I knew that you got so many things to memorize. So now I'm going to use these two formulas, and actually there are a few formulas that you must know. Maybe you can put in the list. It's not given in the list, so maybe you just write tangent A. What is the formula for tangent A? Is actually sine A over cos A, right? So if they ask you cotangent A, it should be 1 over tangent A. So it's actually cos A over sine A. You must know. Alright? And then you must know about the sec A is 1 over cos A. And then cosec A is 1 over sine A, right? Notice that S here, C. Okay, C then S. Okay, so let's see. We are going to write down the other formula, which is not in the list, but you must know, which is sine A over cos A is tangent A. Sine A over cos A is equal to tangent A, and cotangent A is reverse cos A over sine A. Alright, so just by using all this formula, I think you can prove you will get the answer, which is actually sine 2A over 2. So, okay, now I want to teach you how to prove. You always start from left hand side, then you do until you get something which is right hand side. What is our right hand side? Which is sine 2A over 2. Right? Okay, this is the right hand side. That is our destination. We want to achieve this one. Okay, so what you need to do is, okay, let's start from here. You need to show the steps so that you can reach the right hand side. That's so-called proving. Okay, so I'm going to start from here. Basically look at the formula that you copied just now. Just substitute, right? We just use a formula that we copy this formula. Alright, so you just substitute into here. Okay, so let's substitute. So you just plug in the formula. You don't have to memorize. So it's 1 plus tangent square A, right? This is a formula that you got it from the formula list, right? So minus, you can write down, copy back, tangent square A over, when you see tangent A, you will write sine A over cos A. When you see cotangent, you will write cos A over sine A. Okay, just plug in the formula. You can get 1 mark already, you know. It's very easy to get marks for proving. For Trigo, it's very easy to get marks. Finally, you have to simplify. And then you notice that tangent square A and minus tangent square A will be cancelled out, right? These two will be cancelled out. 1 plus, 1 minus. And here, when the denominator are not the same, what must you do? Of course, you will times with the something that will make the denominator the same. So here you time cos A. Here you will times the sine A, you know. You understand? Okay, so that you can join them. Sine A times sine A is sine square A. Cos A times cos A is cos square A. Which is, this one is another formula that you can get it from the formula list. Okay, now if you are sharp enough, you should know what is this. Let's say you don't know. You can't recall. So you go to the formula list, you check. Isn't it there? This is so-called basic identity, you know, basic identity. Okay, so it's equal to 1. We will use it. Why? We will keep on use the formula until we will reach the right hand side. So now you see I almost can simplify like this. So this is equal to 1 and this one cancel out. So finally I will have a simple working like this. I have 1 over sine A cos A, right? Okay, so now let's say let me erase this thing. We prepare the space. I want to reach a sine 2A over 2, sine 2A over 2, which is the right hand side, right? Okay, so we have to show the proper step. So you see now I'm having something like this, 1 divided by this whole thing, 1 over sine A times the cos A, right? So when you divide, you have to make it multiply, right? So it becomes 1 multiplied by sine A cos A over 1, right? So let's say you actually stop here. You are not sure how to do. So don't worry if you don't know how to do. You see you have this formula, right? You just do from bottom up. That means from here, now I want to teach you how to prove. You can't think of how to continue further, so you do it. What is the formula for sine 2a? 2 sine a cos a. Copy down the formula, right? dy by 2. So when you reach here, from here to here, you can't think of. So you can always do from this direction, bottom up. Then you will actually prove that you are getting the answer sine 2a over 2, right? The over 2 is there, so it actually proven. The flow of the step are there. Okay, start from the beginning. You plug in the proper substitution for the sec square, and then you convert the tangent to sine over cos, and then cotangent cos over sine. You'll get 1 mark. Okay, they should give you 1 mark, right? Okay, so you know how to use the formula, for sure they'll give you 1 mark. And another 1 mark is where? Is actually this one. When you see sine 2a over 2, when you have the 2 sine a, when you have the 2 sine a, this step, that one will give you another 1 mark here. So just plug in the formula, that's it. Alright? Okay, that's how you prove for the Trigo. Alright, so I'm sure everyone can do. Just use the formula. Okay, you don't have to memorize. Use the formula, and then study the left hand side and right hand side and simplify. Okay, so I hope you got no problem. Okay, so we have discussed section A, Trigo. You can actually go through and try many questions on your own if you want to excel in Trigo. So I'm going to discuss another one, which is this one. Let me discuss the important question first. Okay, I'm going to discuss number 3. So let's read the question. Number 2, I guess you can do. It's simultaneous equation. So this one is, maybe some of you are not sure how to do, so I will discuss this one. So diagram 2 shows a square sheet with side of 1 meter. The sheet is folded into 2 equal rectangles, and the rectangle is then folded into 2 equal square, and the process continues indefinitely. When you see indefinitely, we think of sum to infinity, right? The shape formed by process become a series of rectangles and squares with the area. The subject is the area. 1 over 2, 1 over 4, 1 over 8. All these are area. Okay, that means the sequence represent area. So we have the rectangle, we have the square, but the first one is a rectangle. Second one is square, and the third one is actually the rectangle again. Right, this is a rectangle. Let me show you. This is a rectangle, the first one, and you notice that the pattern is the third one is rectangle. Okay, and then the even one will be the square, right? You can see that there is a pattern repetition of the pattern number. So now we need, basically when you do GP question, you have to understand what the question mentioned about the sequence. This is the area, right? Area. See, I keep on highlight. This is area. So what the question want you to do is you have to determine the first rectangle or square has an area less than 0.0001 meter square. So since this is representing area, So I'm going to use this one as my GP sequence. A is 1 over 2. R, I have to find 1 over 4 over 1 over 2. I have to show both are common. I can take 1 over 8 divided by 1 over 4 or 1 over 16 divided by 1 over 8. Just 2R, common ratio, right? So 1 over 4 divided by 1 over 2, 1 over 8 divided by 1 over 4. So when you simplify, you get 1 over 4 times 2 over 1, which is 1 over 2. And here is 1 over 8 times 4 over 1, which is also 1 over 2. So we have the common ratio. R is 1 over 2. Now the first term is 1 over 2. The R is 1 over 2. And the question is asking, let's see the question carefully. The first rectangle, okay, or the square. So when we read the question, we know it's actually asking for Tn, right? Because the question never mentioned about the sum. So we use a Tn. We use a Tn formula for GP. This is the GP. A is 1 over 2. R is also 1 over 2, right? And then we will use the Tn less than 0.001 meters. Tn equal to A, R, n minus 1. And the A is 1 over 2. The R is actually 1 over 2, right? So the Tn is less than 0.0001. So the A is 1 over 2. The Tn equal to A, R, n minus 1. So 1 over 2, R also 1 over 2, n is the one that we need to determine less than 0.0001. So now the moment you want to simplify, it's a half, right? So you can say that you times 2 both sides, or you times the 2 to 0.001 times 2, right? So now the terms looks like this, 0.0002, right? So now you cannot use the index. You have to, because the base are not the same, so you have to take log base 10. So I'm going to take log base 10 both sides. Alright. Now bear in mind when you take log, the power you can bring to in front, log 10 1 over 2, and then less than log 10 0.002, right? So now you need to be very careful when you solve this, because you need to be aware that when log with a number which is less than 1, a decimal number will produce the answer which is negative. So if you press a calculator, let's say you press log 2, 0.2. Let's press log 0.5, let's say. You get a negative 0.3010299957, right? So it seems like you're going to divide by a negative number, right? So automatically you have to change a sign when you divide by a negative number, so the sign have to be revert. So log base 10 for 0.0002 over log base 10 1 over 2. So now if you press your calculator, you will have to revert the sign when you divide by a negative number. Now you can start to press your calculator, and then you just divide with a 0.5, log 0.5, you get 12.2877 something. So it seems like your n will be more than 13.2877. And the question is asking for the first. You see you're having a number 13 you have 14, and then this number that your n must be an integer, is a number of term, so you have 13.2877 here. So of course you will choose the first n, which is 14, so n is 14. And because it's an even number, so it's a square, right? It's a square because the question asks you to determine whether it's a square or not. All right, state whether the rectangle is a square or a square or rectangle. So because we notice that one term, number 1, number 3, number 5 is actually a rectangle, and the 2, the 4th, and the 6th will be the square. So the even number is the square, right? Okay, find the total area. Next question. Find the total area of the rectangle in the series. Total area. So since we actually have two series, one is rectangle and one is square, so let's list out the rectangle. We just focus on the rectangle. It seems that rectangle, the first one is 1/2, right? Okay, the second one is a square, so we don't want. We just want the rectangle, and we have one more. It should be 1/32, right? So the question is asking you to find the sum for the area for the rectangle in this series. Is an indefinite series, meaning that it will continue from 1/2 to 1/8, then to 1/32, right? So let's see, for B, we have to list out. Normally when we do GP, we have to list out the first three terms, so 1/2, 1/8, and 1/32, and it will continue indefinitely, means it will continue never ending. So we knew that it's actually infinity, sum to infinity, meaning that you are going to sum up everything like this until never ending, so this is called sum to infinity. So we need to find that A is 1/2 and the R is 1/8 divided by 1/2, so it's 1/4, right? And you have to show that both R are common, they are the same, like this, 1/8, so you get 1/4, right? Okay, you can always use a calculator to check. So sum to infinity is A over 1 minus R. So the sum to infinity is actually sum for every term until the infinity term. So the A is 1/2 and the R is 1/4. So if you simplify, you get 1/2 over 3/4. Finally, you get 1/2 times 4/3. So you get 2/3 is the sum to infinity. So this is the answer. Sum to infinity is 2/3. Okay, for the AP or GP, the way to do is you must very sure you have 3 terms, and you try to work out the common ratio. If it is GP, and if it is AP, you'll get a common difference, right? Okay, so I have discussed 2 questions on how to solve the trigonometric and the arithmetic progression. Alright, now I would like to continue with another question, which is let's see, the next question is very interesting hot question. So okay, I'm going to discuss this one. Okay. For paper 2, you might see question like this. Okay, so you see you have a car skidded due to the slippery road. Okay, so it seems like it applies to which topic when you see this question. You're having a curve, and then there is a point on the curve, and then from that point actually you can see there is a straight line, right? So the concept of this question is basically about the curve and a straight line on the curve. So we call as tangent, right? When you see a curve, right, you will always use a concept of differentiation, right? So this is a straight line passes through the point on the curve. Alright, so now this one, when you see the curve and a straight line which is a tangent to the curve, the moment you see the tangent to the curve, you would think about dy dx. Okay, so how to differentiate this one? You are having y equal to 3, you have to raise up to the power of -1. Okay, and they give you the condition y must be positive. Okay, so now the car skidded in a straight line and such that the tangent to the curve with a gradient given -3/2. Okay, that means the value of dy dx was given. So let's see how to solve this. Okay, so first thing we try to differentiate. Okay, we try to differentiate it. Okay, how to differentiate? You still remember how to differentiate this? So you have y equal to 3, 2x minus 2 to the power of -1. So dy dx is chain rule -1, then times 3, then 2x minus 2, and minus 1 minus 1. And don't forget, you have to differentiate inside the bracket. No, this is the part that people always forget. Differentiate the 2x minus 2. So 2x, you will get 2. So finally, your dy dx is -6 2x minus 2 to the power of -2. And then you have to write in fraction because it's easier for you to solve later on. Okay, so square. And you see, you are given the gradient, meaning that the dy dx value was given. So you can just substitute and then you can equate and solve the x, right? Basically, this is how you do for the equation of tangent. Alright, so we are going to cross multiply carefully. Multiply like this. Okay, so maybe you can cut this on 3 and 2. So it becomes 4, right? 4 equal to 2x minus 2 square. You understand? Or you can cross multiply slowly, but we want to go fast. So we actually don't expand. We see the square. We should be able to do it by completing the square. And then we will square root the 4. You should have 2 answers. So one is x positive, so your x is 4 divided by 2, which is 2. The other one will be 2x minus 2 equal to -2, so your x is 0. So we have 2 points, x2, x0. But because the condition was given here, when your x is 2, we check, are we getting y positive? So we will accept this. When x is 0, we will get y is negative 3 over -2. So we will reject this one. We will reject. So we will accept x equal to 2, y equal to 1. Got it? Okay, so now the next question is asking you, okay, so we have actually found out the x value. Okay, given the equation, okay, now we're asking to, if there is a construction, okay, cone on the waist side located 1, 3, will the car hit the cone? Justify your answer. So actually just now we have the point, and this point is at the 2 and 1. So we have 1 point, and we are asking to determine whether the car will hit the cone. So we are not sure the position, but we have the coordinate is 1 3, but we are not sure whether this point 1 3 will lies on the line or not. If it is lies on the line, then we try to find the gradient. If the gradient produced is the same like gradient to the curve just now, -3/2, by using 1 3, then we can say that the point is actually lies on the line, and then actually the car will hit the cone, right? So now let's try to find the gradient of this point 1 3. Okay, so let's do it here. So let's see, we have 2.2. Okay, imagine that this is a point cone. We use C. This is the point 10 at the curve, so we call it point A. MAC. AC is the same with the gradient of the tangent to the curve. Then we can say that the car will hit the cone. So y2 is 3, y1 is 3/2, x1 is 1, x2 is 2. So the gradient of line AC is 3/2 over -1. So it means that I'm getting the gradient is -3/2, and this gradient is equal to gradient of the tangent to the curve. Gradient of the tangent to the curve. Hence we can say that the car actually will hit the cone. Why? Because when we try to find the gradient, and the gradient of the point 3, the point 1 3 with the point on the curve, the gradient are actually equal to the gradient of the tangent to the curve, right? So we can say that the car will hit the cone. Alright, or maybe you can use the equation. You find the equation of tangent. We find the equation of tangent. Okay, let's find the equation of tangent, the blue line there. So the blue line there is having gradient m is the same with the gradient of the tangent to the curve at a point which is -3/2. And then because we have the point was given we have the point 2 and 0, right? 2 and let's say, okay, we write down the x is 2, and we have the y is what is the y? The y is, let's substitute, 3/2x minus 2. 3/2 times 2 minus 2, so we have 3/2. That means the point will on the curve will be 2 and 3/2, right? So we can form the equation of the tangent. Let's write down y equal to mx plus c. Okay, the y is 3/2, right? The y is 3/2, and the gradient is -3/2 times the 2 plus c. So we try to find 3/2 equal to -3 plus c. So hence the c is 3/2 plus 3, which is 9/2. So now the equation of the tangent is -3/2 x plus 9/2. So if the point 1 3 lies on the line, if lies on equation of tangent to the curve, Then when you substitute, it actually will satisfy the equation. Alright, meaning that it will give the same value. So now we can do like that. We have the x is 1, so we substitute the x into the equation. We will get the value which is we have negative 3/2 x plus 9/2. This is 9/2. So let's substitute carefully. We have 9 minus 3, which is negative 3 plus 9/2. We have 6/2 and we getting 3, right? So it means that the 1,3, the 0.13 is lies on the equation of tangent. Okay, it means that the car will hit the cone because the cone is at the point 1,3. Hence, the car will actually hit the according to the question, if there is a construction cone at the wayside, will the car hit the cone? Justify your answer. So how to do 0.13 is lies on the equation of tangent to the curve. That's how we justify. Let's write properly to the curve at a point. Equation of tangent is always at a point. Okay, equation of tangent at a point. The point is 2 and then 3/2, right? The point is at 2 and 3/2, right? Correct. The point is lies on equation of tangent to the curve at 0.32. Okay. Hence the car will hit the construction cone. Okay, that's how you answer. All right, so this is basically about the Hodge question for differentiation. So what you need to do is you must understand that dy dx means a gradient at one point for the tangent for the blue line. Okay, so when you do dy dx, it means a gradient of the tangent, a straight line that touch a curve at a point. Okay, so we have discussed this one, and now I would like to discuss another one. This one is quite easy, right? This is quite easy, so we discuss this one. So diagram 4 show the coordinates of point R as T on a Cartesian plane. So Cartesian plane is easy. Find the equation line which passes through point T and perpendicular to the point to the straight line RS. Okay, meaning that perpendicular to RS, so that means we have to find the gradient for RS. Okay, so MRS is equal to 9 minus 3 over 2 minus 4. So 9 minus 3 is 6, negative 2 minus 4 is negative. So the answer for the gradient RS is negative 3. So it's saying that the equation of normal is passes through the point T. So let's draw like this. This is the red one is equation of normal. Okay, normal. This is normal. The blue one is tangent. So if M2, what is the M2? M2 will be negative or positive. Should be positive 1/3 because the M1 is positive. So if you are not sure, you always use M1 times M2 equal to negative 1, right? So if we try to solve it, negative 1 over m1, which is negative 3. So we are doing the right thing. So the m2 is a positive gradient. That's why the line is heading up. Okay, so we are asking to find the equation of straight line passes through point T. Point T. Okay, so we have the gradient, we have the point. So we can use y minus 4 equal to 1 over 3x plus minus become plus 3. You can use y equal to mx plus c if you want, but I think I prefer this way. So it's up to you. You can choose the method you feel more confident with. So this is the equation that passes through point T and perpendicular to RS. Alright, so we have solved the perpendicular. Okay, so now the point P, the moment you see move, you quickly write x, y because it keep on moving. So it's unknown point. And the distance from the midpoint RS is 5 units. Midpoint we need to find, and the distance is 5 units. Okay, so let's see where is the midpoint for RS. Midpoint, it should be at the middle, right? So we are going to plot here. This is a midpoint. So let's find out the midpoint. It will be the midpoint will be m 2 plus 4 divided by 2, 9 plus 3 divided by 2. So m is 3 and 6, right? So now we need to find the equation, a locus that passes through 3, 6. Okay, 3, 6. Okay, and then distance is 5, is fixed. So let's find the equation. Okay, so the equation of the locus is always using distance, right? Okay, so let's see. The P is, let's list out all the point x, y, and the m is 3, 6, right? So we are going to solve this. Okay, let's see. So what space? Okay, now let's see. We find a space to write. Okay, so now we have the point P and point M. Point P is moving point. Point M is 3, 6, and the condition of the locus is PM equal to 5, right? Now let's apply the distance formula. X minus 3 square plus y minus 6 square is equal to 5. Okay, that is the distance formula. So we can squaring both sides, right? Can you? Right, let's square both sides. So I'm going to use a red pen so that you are aware when I square, the square root will be cancelled out. So left only x squared minus 6x plus 9 plus y squared minus 12y plus 36 equal to 25. And if I simplify x squared plus y squared minus 6x minus 12y plus 45 minus 25, 45 minus 25 will be plus 20, right? So this is so-called equation of the locus. So next question, they will ask you about the equation of locus will touch the axis of the x, right? So let's go through the question first before we apply the concept. So the next question is, okay, let's see this question. Show the locus does not intersect the x-axis. So we have three scenarios. Locus, okay, above the x-axis cutting, and then the last one is the locus lies on the x-axis. So this one is b squared minus 4ac more than 0. This is b squared minus 4ac less than 0. This is b squared minus 4ac equals 0. So we will choose this one. Does not intersect, right? So you go back to the equation just now. This is the equation of locus. So because of the scenario is like this, does not intersect the x-axis. This is a locus equation. So we will let y0. Substitute y0. We will have the x squared minus 6x plus 20 equal to 0. Right, we want to show that if we let the y 0, we actually cannot find the roots of the equation. It also means that b squared minus 4ac will be less than 0. So what you need to do is you find out the ABC, right? You find out the ABC, then you substitute into the b squared minus 4ac, and then you check the b squared minus 4ac, is it negative or not. Alright, so it's quite simple. You want to show that it has no roots. A is 1, B is negative 6, C is 20. So what you need to write is you write b squared minus 4ac. Don't write less than 0. Okay, you substitute negative 6 squared minus 4 times 20. So you have the 36 minus 80. Yes, you are having negative value. So sin b squared minus 4ac less than 0. Hence, the locus does not intersect the x-axis. Alright, that is how you show. Okay, if you have b squared minus 4ac equal to 0, means that the locus touches the x-axis. If you have b squared minus 4ac more than 0, it means that the locus equation intersect the x-axis at two different places, 2 points of intersection. Okay, that is the concept of the section A. Okay, we still have one more question, which is statistic, right? So let me finish it. The statistic question. Okay, let's see. We have the curve. Okay, this one. So this question is basically quite easy because it's about statistic. So you see, this is a data of blip test of two group of students. You have two groups. Okay, there are some splash of ink that dirty the data, so it's okay. We still can do the calculation. Mean of the data of the omega group. Omega group is here, right? So we are going to find mean. So when we see we have standard deviation, we have sum of data square, we will use the variance formula, right? So let's use a variance formula. Okay, so what is the formula for variance? Variance is actually standard deviation square, right? So we will take the standard deviation with square. So let's write down. This is a variance, sum of data square over n minus mean square. So we're asking to find mean, right? Okay, so the standard deviation is given to 4 in the table, and this was given in the table, and we have 5 data. So minus the mean square. Finally, mean square is 260 over 5 minus 16. So you will get the answer for mean square is is 36. So hence mean is 6. Alright, Now we will actually discuss, given that the mean of omega group and gamma group are the same, mean are the same, find the variance of the combined data. Okay, so you want to combine the data, you must have the information about the omega group and the gamma group for all the information. So we have n equal to 5, n equal to 4. We have the mean, just now we have 6, this one also means 6. Okay, so mean you can write this. Okay, they are having the same mean, and if I look at that, I have the sum of the data square is 260. Sum of data square here is we have 4 data, we have 4, and then we have we don't have the sum of data, so let's find the sum of data. Okay, sum of the data is given by we have to take we have 5 times 6, 30, right? Okay, 30 for this one. Sum of data is 6 times with the just now the okay, we have the 6 times with the 4 data, mean is 624. Okay, so we have almost all the information except the sum of data square, so we need to find this one first. Okay, let's work out for that first. So we use the, okay, let's work out here, sum of the over n minus mean square equal to variance. Okay, we have the variance 5, isn't it? So this is 5 square. So we have the mean same, we have sum of x squared that we are not sure, and we have the n 4. So the sum of the data square is 5 square plus 6 square times 4. Okay, so 25 plus 36 times 4, we get 200, and the sum of the is 244. So 244, right? So we have all the information ready, right? Then we can combine to find the combined variance. How to find the combined variance? We need to combine the sum of data square for both, right? We need to combine these two, and we need to combine the sum, which is 30 and 24, meaning that we have to find a new mean, right? Okay, after we combine, we have to find the, okay, let me find a space to do. Okay, we have the space or not? Here. Okay, here. Now we talk about the combine, right? Combine meaning that we have to, okay, we need to have the sum of the data square for both. So we have 260 plus 244, and we have the sum of data, which is 30 plus 24. We have the number of data, which is 5 plus 4. Okay, now we can find the variance for the combined one will be 260 plus 244 over 5 plus 4 minus 30 plus 24, which is the new mean, over 5 plus 4 square, right? So then you will get the answer. If you combine, you have to combine everything. Sum of data square, the number from 5 become 9, 5 and 4, 5 plus 4 become 9, and total you will get the variance. It should be equal to 20. Alright, so please take note that you have to combine like that to find the combined variance. Okay, understand? So I have discussed the section A for paper paper 2, which is actually a bit challenging. I think there's still one more question, and this question I think many of you can do, right? I'm sure you can do because it's quite simple, right? Okay, how to do this question? Let's go very fast. It's about the what topic? What do you think? Which topic you will apply? Okay, so you are given a rectangular shape, right? You're given a rectangular shape. So let's see. Okay, let's read the question. Aino bakes 2 kg cakes. Okay, 2 kg cakes. And then height is 10. She wraps around the side of the cake with the ribbon measuring 57. Okay, so let's see the cake. Okay, so the ribbon, we have the length here and the width. We have length and width. So first information we can write 2 length and 2 width is equal to 57. Alright, and then 1 kg is equal to 1000. 1 kg is equal to 1000 cubic. So that means we will take the length and width we multiply, right? 2 kg, you have 2 kg cake. Okay, 2 kg cake. 1 kg is 1000. So 2 kg will be 2000, right? Cubic centimeter, right? So now the height is 10. That means the surface area. A times 10 is 2000, is the volume, right? So the area is 200. That's how you calculate. So that means you take the length times the width is the surface area is equal to 200, right? Okay, so you come up with a equation 2L plus 2W equal to 57, and then you have the LW is equal to 200. So let's say L is 200 over W. You substitute 1 into 2, right? So let's substitute 2 times 200 over W plus 2W equal to 57, right? Okay, now you need to solve it carefully. 400W plus 2W equal to 57. Okay, now what you need to do is you have to make the denominator the same, right? So where is it? Okay, here. Now I'm going to multiply by what do you think you need to multiply? I will multiply by a number which is W, both sides. Easy, right? So I have 400, cut. This one W multiply in plus 2W square is equal to 57W. Now you have to rewrite until you can see a quadratic, right? Okay, after you see the quadratic equation, you can factorize. If you can factorize, then you factorize. So I'm going to factorize. So let me see how to factorize. So I will have, here is 25, here 2W, W 25. Okay, 400 divided by 25. What you get? 400 divided by 25. You got 16. Alright, so then you can say 2W minus 25 equal to 0. W is 25 over 2 or 12 and a half. And the other factor equal to 0, so W equal to 16. So you have two possible answers. Either your W is, if your LW is equal to 200, so if W is 16, then the L is 200 over 16. Okay, 200 over 16. What is the length? You will get 12 over 12 and a half. If you are using 12 and a half, you will get the length is 200 over 12.5. Let's see, 200 over 12.5, you get 16, right? So it can be either a rectangle in this shape, okay, or in this shape. There are two possible shapes. So there are two possible. So then the area is still 200. So if this one, it will be 12.5 logically. Here will be 16. If this shape you putting this way, it will be like this. So logically is this is the length. Okay, the length is here. This is the length and this is the width. And for this one, this is the length, this is the width. Alright, so the area is 200, right? So basically the L and W, you can give me either 16, L 16, W 12 and a half, or you can give me W is 12 and a half. Okay, you can give me the other way around. You can give me the L or the other one. W is 60, right? So these are the possible answers. Okay, so in short, these are the questions for section A, paper 1, paper 2, which are a bit challenging. So you need to be well prepared and you must do fast. The speed of doing is very important. Okay, so keep on practice and I'm sure you will get A+. Till then, I shall see you in another video sharing. Bye bye and have a nice day and take care.